Hey guys, here's our lesson today on estimating area under a curve. We're going to start with remembering one of our really important shapes. Remember, I told you a couple weeks ago now that this trapezoid and finding the area is super important. So we're going to work on this, and I'll give you some more explanation of what you'll be working on today. Originally, today, I was supposed to have B day, and I don't have in the afternoon any classes except for acceleration, and I'm going to be gone this afternoon. So, hence, now you have a video. All right. So, remember, you can always email or text me, or same with Miss Kohlhauer if you need help or have any questions on what you need to do. First, we're going to start with finding the area of this trapezoid here. So, to find the area of a trapezoid, we take our two bases and we add them together. Once we've added them together, we divide them by 2, and then we take that number and we multiply it times the height of the whole thing. We know this one's the height because it goes from one of the bases all the way up to a top vertex here. So we have our two bases. Our first base is 6, our second one is 8, so 6 plus 8. And then we want to divide that by 2 after we add. And then once we do that, we're going to multiply by 4 because that is our height. So when we add 6 and 8 together, it's going to be 14 divided by 2. And then when we do that, we're going to multiply by 4. So first we're going to start here with the 14 divided by 2. And that's going to give us 7. And then we still have to multiply by 4, so our area will be equal to 28. And we don't know how many, like what our units are. We don't know if it's centimeters, meters, inches, feet, yards, whatever. So we're going to say units squared because it's area. All right, so let's get started here. Today is actually an A day, but we're talking about estimating area under a curve. And we're looking at completing 2 different things that each only have 2 questions. So you can totally get it done. But make sure in Elluminate you take your time. So we're going to exit ticket and Elluminate. And we've got our Delta Math assignment here. Okay, so we're looking at estimating area of curved regions, graphed, and also just under a curve in general and how to estimate that. All right, so first we're going to start off with something we can kind of verify with the math that we know and kind of just double check it and see how close we can actually get. So we're going to start with this triangle here. So we have an underestimate and an overestimate. So for our underestimate, we're going to look at how many whole squares are inside here. So we're going to get smaller or less than the actual amount of area. So we have got 1, 2, 3, 4, 5, 6, 7, 8. These are pretty close. So I'm going to count them. So we've got 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 28, 29, 30, 31, 32, 33, 34. So my underestimate, meaning I know it's less than the area it actually takes up, which I'm going to also include these 2, so 36, and like 2 more. I know it covers more than that, but I do know it's pretty close. So now that I know what it is a little bit less than, I'm going to find something that's over. So this is going to be my overestimate. And once I have the 2 of them, I'm just going to average them together. So if I'm looking at an overestimate here, it means I'm going to go outside. I'm going to count everything that it goes through or it touches. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 6, 51, 52. All right. So my overestimate is 52. So the actual amount of space that this triangle takes up is somewhere in between 36 and 52. So my best estimate is going to be somewhere in between 36 and 52. So what I'm going to do is I'm going to average them. And we're taking ourselves all the way back to middle school when we were learning about averaging. And since we're adding two things together and we want to find the average of those two things, we're going to divide by 2. So I'm going to add them together and then divide by 2. So you're going to need your phone for your calculator or Desmos, or if you have Mr. Reether, you might like using calculator.net. Either one of those things are fine. So you just want to make sure you've got something to use. So we're going to add 36 plus 52 together. We get 88. So this is going to equal, we've got 88. We still need to divide that 88 by 2. Okay, so that's dividing that 88 by 2 is going to give us our average estimate of what kind of area that takes up. So we've got 44 is it's a pretty good estimate. It's like somewhere in between there. And then we want to take a look at, okay, our actual formula. So remember, we know what the formula is for a triangle. The area is equal to 1/2 the base times the height. So we're going to look and we're going to measure the base and the height here. And we're going to check and see, how different or how close we got with our guess. All right, so the height, remember, is from the top all the way down here. So this is our height. So let's count it real quick. Our height, so it goes from 0 to 6 here. That's 6. Plus it goes down to 5. So our height is equal to 11. And now let's take a look at our base. So we're going from this point all the way to here. So remember, a base connects two vertices together. So two of those vertices are two angles, and it's a side. And the height connects the base to one top vertice. It's kind of how to figure out which one is the base and which one's the height. We want to measure how tall it is. Now we're going to measure how wide. We need to go from here to here. So on this side, it goes to 4, and on this side, it goes to 4. So that means our base is 4 plus 4, or 8. Or you can count the squares. 1, 2, 3, 4, 5, 6, 7, 8. And the same thing with your height. You can count the squares. All right, so we know what our base and our height is, so we can now check it. So we want to do 1/2 my base times the height. So my base is 8. And my height is not 1. My height is 11. Because I've got 5 and then 6. And it looks like we actually did really good here, because we have 1/2. 8 times 11 is 88. And then we want to cut it in half. We get 44, so we get the exact same answer. So we did really good. So using our actual formula here, we got the correct answer. All right, so let's take a look at a new one. So a different example, and here's ones that we'll be focusing on. Ones that are curved. So it's really hard. We can't really verify it, but we know that if we follow that same method we just did with finding the underestimate and the overestimate, we can get either almost the same thing or really close. So for our underestimate, we're just going to do the ones that are all the way inside or almost all the way inside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 28, 29, 30, 31, 32, 33, 34, 35, 40, 41, 42, 43, 44. All right, so our underestimate is 44. Now, you can always pause this video and try this on your own and see if you get the same answer. Because really, this is a little bit different. It just takes practice. So at any point, go ahead. You can pause the video and try it yourself and see if you get the same thing. And just play it whenever you're ready. All right, so we've got our underestimate. Now let's do our overestimate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 9, 30, 38, 39, 40, 41, 48, 49, 50, 51, 52, 53, 54, 55, 56. All right, so I counted 56 squares for overestimate. So we're gonna do the same thing to get our average. Since that's what we want an average. That's gonna be our final answer. So basically we want half of 44 plus 56. So half of our underestimate plus our overestimate. So we're going to take our calculator here. We're going to add up 44 and 56. And we get a solid 100. So we need to get half of 100. That's the same as 100 divided by 2. And we all know that's 50. So our average estimate is about 50. So we know that it covers about 50 square units, whatever those units are, those little 50 squares. All right, so let's try another one. Okay, while it loads. Maybe. Have a cup of coffee, by the way. There we go. All right, so we're first going to do, this is an overestimate. Notice it's an overestimate because it goes outside of those curved lines. And our other one is an underestimate because it goes inside and doesn't quite get everything. So we're going to start counting here. So I've got 1, 2 and a half, 3, 4, I have another half, 5, 6, and I'm using a whole number for the ones that are completely filled, 9, 10, 11, 12. So right here, I've got 12 plus, I have 2 halves. So a half plus a half is equal to 1. So we're adding 12 plus 1, and we get 13. So our overestimate is 13. Now let's check our underestimate. So we're so notice we've got some half ones here. So I've got a half. I've got a half. 1, 2, 3, 4, 5, 6. I have 2 more halves. So 6 and 4 halves. So it's 6 plus I've got 1 half plus another half plus I've got another half plus another half. All right, so first of all, we know that this is equal to 1 and this one is equal to 1. So we're adding 6 plus 2 more. So this is going to give us 8 for our underestimate. So to get our average estimate here, I'm going to find half of 13 plus 8. So 13 plus 8 is 21. We're going to put our half out there first. So half of 21 is going to be 10.5. So our average estimate is about 10 and a half. It covers about 10 and a half square units. We need calculus to actually verify what the exact amount is, but I'm pretty confident we've got a pretty good estimate here. All right, so let's take a look at this one. We've got this one and one more. So first of all, it says approximate the area. So we're estimating, doesn't have to be exact, under the curve from t equals 15 to t equals 30. So first, let's block off here and over there which ones we're going to need exactly. This is the only information that's going to be helpful to us right here in that box. All right, and let's also make some, first let's do an underestimate and then we'll do an overestimate. I'm also going to set this up for us, because we're going to look at the average of all of our estimates here and use that to figure out what we've got. Okay, so we're going to have this help us figure out what we've got for our final answer here. But first, we need to make some boxes. So by boxes, I mean rectangles. We're going to do an underestimate and we're going to do an overestimate. So it has to start at 15. And because we're going from 15 to 30. Notice down here in the bottom, our interval is 5. So if we're finding the area under the curve, we're going to find the area of each of these rectangles. And we're going to do it twice. Once for underestimate and once for overestimate. And so let's start with an underestimate. If we do it this way, with the left part of our box hitting that curve, notice we don't get everything up there. We're going to be missing some pieces. So this is our underestimate. And we only want to go and make enough boxes or rectangles until we get to 30. So we only need 3. So notice down here in the bottom, the interval is 5. And we can use, and it hits from 15 to go up to here. We could look right here at the graph. We can also look here at the table information. We know this is 30. So the side of our rectangle is 30. So the area of this one is going to be 30 times 50, or 150. And I can actually write that in. I'm going to write it in right over here. So this is our first underestimate, 150. And now we're going to do that for all of these. And remember, the interval is the same here. So it's going to be 5 and 5 for all of these. And this one, I'm going to go all the way up to here. This is at 20. It hits the graph at 55. So I know that this is 55. So I need to do the area there. To get the area, I need to do 5 times 55. So I'm going to make sure I got it all the way correct here. 5 times 55, we get 275 for our area because we're multiplying those together. So I'm going to put that here as my second rectangle, 275. And if you've got this, I want you to try and do it yourself. Go ahead and hit pause. And then once you have your answer, see if you got the same thing. And then for our last underestimate, we know that the interval is 5, so the space down here is 5. And then the height of this is up at 70. I can also see that here. So I'm doing 70 times 5, that's 350. So I'm going to put that right here. So now I have all of my underestimates. I'm going to have to do my overestimates. So I'm going to come over here. I'm going to erase what I've got. And I'm going to do the whole thing again. But I'm going to have my rectangles sit on the other side of the graph. So I get too much instead of not enough. Okay, same thing. I can only go from 15 to 30. So notice this one is my overestimate because I have all the space above the graph there. And I only need 3 rectangles again because I'm still only going from 15 to 30. My rectangle's not perfect. That's all right. All right, so let's go ahead and check on these here. So remember, the interval is still 5, so this is all going to be the same. This one hits the graph here at 20, so that will be 55. So I do 5 times 55, and that's going to give me 275. I already did that one, that other calculation, and that underestimate is there. And then I'm going to do the same thing again, 5. This one's hitting at 70, so the area for this one is going to be 350. I did that other calculation there also, so 350. And then we're going to do one more calculation here. This is still 5. This one hits all the way up at 78. So I need to do, for the area, I need to do 78 times 5. 78 times 5 is going to get me 390. Okay, so then I stick this right here. So now I have a nice way to show how to put all of these squares together to get the areas of the rectangles together to find the average of all of them. So the average of the first one, average of the second, average of the third, and when I put them together, I should get a nice little estimate there. So if I did some adding, I'd have 1/2 of, I add 150 and 275, I get 425 plus, let's make this. Let's change the color so we can see it's different. I want it right there. We go. 1/2. We want to find 1/2 of this next sum. So we add 275 and 350 together. We get 625. Plus, we want to find 1/2 of our next one. So we add 350, 390, we get 740. Make it a little smaller so it fits right there. Okay, so now the last thing we need to do is find 1/2 of all those numbers and then add them together. So 1/2 of 425 is 212.5 plus 1/2 of 625 is 312.5. And then we find 1/2 of 740, and that's 370. So then we add all 3 of those together, to get our final answer, so we do 370 plus 312.5 plus 212.5, we get 895. And we're talking about feet per second squared. All right. So we have one last one to try, and then we all set to go. This one, as we're going through it, I want you to also take notice that since this one is a symmetrical curve, and it's sitting right on the y-axis, the very center of it is, we should get the same sum on the left and the same sum on the right. We're just going to practice putting it in there. All right, so for this first one, notice first of all that all of my interval is 1. So it's going to be 1 on the bottom of all of them. And we're going to take a guess here about the height of this one. I'm going to say it's about 0.25. If you want to say it's a third, that would also work just pretty close. This one has a height of 3. This one has a height of 4 and a height of 3 once again. So the area of this one, we multiply 1 times 0.25. And we get 0.25. So the area of this one is 0.25. The area of this one's going to be 3, because 3 times 1 is 3. Area of this one's going to be 4, because if I multiply my two sides, 1 times 4, I get 4. Area of this one is 3, because 1 times 3 is 3. So I'm going to add those 4 together. So 0.25 plus 3 plus 4 plus 3. So I get 7 plus 3 more is 10 plus that 0.25. So I have 10 and a quarter, 10 and 1/4, 10.25, all the same. So 10.25. And if we're trying to make it look like our other one big long equation there, I'm going to put each of my sums or my areas here that I summed together for my left sum. And now I'm going to do the same thing for my right. So these all have an interval of 1 here. So each of the length or width of these rectangles are 1. And we're going to check the height now. So the height of this one is 3, making the area 3. All right, the height of this one is 4. So the area is 1 times 4, so that's 4. The height of this one is 3. So area is 3 times 1, which is 3. And this one is about 0.25 for the height. So my area is 0.25. And it's the exact same thing as over here. So if I add all of these together, I get the same number. So first of all, if I add them together and divide it by 2, I'm going to get the same answer. So I already know that my average estimate is going to be the same because I got the same using the left and the right. And it should have been that way because it's symmetrical over the y and the x-axis. It hits in the same amount of space on each side. So now we're going to take a look at just practicing writing this one in here. So the first area on the starting from left to right was 3. And then we had 4, 3, and 0.25. And since all of our, both of our left sums and our right sum of areas were the same, so our average is going to be the same also. All right, so you can find the estimate of an area under curved or curved areas. You find the average sums of the areas of rectangles under the curve. So we do half times the overestimate plus the underestimate. And that's it. So today you have area under curve and Delta Math 2 questions, and then your Elluminate exit ticket. Please do that today. Also, I think only 2 questions. For you guys, it will be due on the 2nd of March. So I will see you then. I hope you all have a wonderful day.